Okay, so another example to do with forces vectors. The particle begins at rest at the origin, it is acted on by three forces, 2I add j newtons, 3I subtract 2j newtons, and minus I plus 4j newtons. I'm going to find the resultant force. I'm then going to work out the magnitude and bearing of the resultant force, and then we're going to describe the motion of the particle. So the resultant force is simply adding together the three forces that are acting on this particle. So that's 2I add j, add 3I subtract 2j, subtract I, add 4j. So if we simplify that, we've got 2 add 3, subtract 1 for I, so 4I. And then look at the j terms, 1, subtract 2, add 4, is going to be 3. So it's 4I add 3j. Part B, we want to work out the magnitude and bearing of this force. So it's 4I add j. So that's like this, in other words. So 4I add 3j rather. So getting the magnitude of the vector, that's just Pythagoras. So the magnitude is square root of 3 squared add 4 squared, which is 5. You might have recognised it as being a 3, 4, 5 triangle. We want to get the bearing, so we're going to be looking for the angle here. Well, to find that, we could perhaps find the angle here and then subtract it from 90. So opposite, adjacent. So therefore tan theta is equal to 3/4. So we just need to inverse tan of that, which is 36.9 degrees. So the bearing is this bit. So 90 subtract 36.9, so 053.1 degrees for the bearing. And then describe the motion of the particle. Well, all we're really saying there is that it's going to accelerate in the direction of the resultant force.